An ecosystem matrix, how we envision it is a collection of data that's been gathered up in a structured way. So it includes multiple variables that describe the ecosystem, and these can be physical variables such as bottom water temperature, or they can be biological variables such as calinus copepod abundance. At present, we have 387 variables that exist in the ecosystem matrix, and they are all provided on a common spatial scale. And indeed, we have things even like climate projections in the ecosystem matrix. Data integration and accessing data is a challenge, and it's a challenge in the Gulf of St. Lawrence region, but it's not only in the Gulf of St. Lawrence region. I'd suggest that the problem is generic. Yeah, you can see it in the North Atlantic, where we have probably the most data sets of anywhere in the world, and you can see it in the North Pacific. People don't necessarily have access to data at the proper temporal and spatial scales. And this disparate data storage that we have on multiple data sets falls generally to one particular person in a government agency to provide that data. And it might not be provided at the scale that the analyst wants it or needs it to do their analysis. As well, because of that, the analyst might go back to the data provider multiple times, making multiple requests, and that puts a lot of burden on this person, usually one particular person. And by packaging things at the proper scale, bringing all sorts of disparate data sets together, that reduces the burden on a particular person, but it also allows an analyst to have access to multiple kinds of data in one place. The matrix as well is fully transparent in that you can trace every single variable back to a key reference, as well as the data provider, and the contact details for the data provider are there. So there is a full traceable transparency that going right back to the data collection. And in addition, it provides a certain amount of acknowledgement of the data provider. These people sometimes are doing an awful lot of work in the background, but when an analysis comes out at the end in a scientific paper, that person might not be acknowledged. And that we find that to be an issue. And this can be really important even for their own career development. And that can be what they are judged against. So we want to create this traceable line so that the proper people get acknowledged, as well as if you have questions about the data, you can go right back to the source. With the way that we've operationalized the ecosystem matrix is through an R package. Most marine scientists, at least the biological marine scientists, are working in R right now, which is an open source piece of software for statistical analysis and data handling. And by creating an R package, we allow the analyst to bring these data directly into their workflow, as opposed to going to a different website, downloading data, having it in their downloads folder. Maybe the downloads are named download 1, download 2, download 3. They quickly lose track of what it's all about, and it creates an awful lot of time to be dealing with these data, bringing it into their analysis. So by doing the R package approach, we allow one to already use the tools that they're familiar with. If they don't use R, they can also download the single Excel web sheet and import it into their software of choice. The R package has really basic functionality. We don't want it to do a lot of things. We essentially just want the package to make data available to many people as easily and quickly as possible. It's fully open. It's available on GitHub to anybody in the world. It requires no permissions and it has no restrictions on it. And as a result, this is really can be quite useful for many people, including the public, not just scientists, even though that's where we aim mostly, but it can be used by fishery managers as well. And so we consider this to be a step forward in transparency and openness and data provision. The ecosystem matrix has been put into this R package that we call GSLEA. And it has been used in several analyses already in the Gulf of St. Lawrence. For example, it's been used to look at the impact of bottom water and temperature on the productivity of some of the shrimp stocks in the Gulf. We've used the climate projections that are available in the package to help develop recovery planning scenarios for stocks that have been depleted. It's been used for a couple of herring stocks to look at the effects of temperature and things like dissolved oxygen on the productivity of those stocks. Greenland halibut as well, similar sort of things. We've used it. We have a small relict population of beluga whales in the Gulf of St. Lawrence, which is normally an Arctic species, but they exist here in very low abundance. And it has been used to look at some of the food supply for the beluga whales. So it has had uses in terms of the analysis, but it's also had a use in terms of reducing some of the burden on the data providers that are in our institute, my institute. As a result, those people can concentrate on some other data requests while the analysts use this package to explore some initial hypotheses, and they can come back to the data providers later if they have more refined requests. But it's proven already to be kind of a useful approach. This definitely can be used in other areas. You can take the package as a whole and put your own data in it, and then use all the functionality that exists, or just take pieces out of it. However one wants to use it, that's fine. No permission required.